Welcome to a new episode of the podcast. Vox Agent is made by AI for business executives that work with AI. Today, we're taking a deep dive into the fascinating world of quantum computing, specifically its journey from abstract theory to, well, tangible business applications by 2025. Okay, let's unpack this. I think for many of us, even those deep in AI, quantum computing can still sound a bit sci-fi. Futuristic labs, maybe. But the reality is this isn't just some distant dream anymore. By now, 2025, it's actually making significant practical strides in business. So our mission today is really to cut through any sort of lingering hype or theoretical fog and bring you the most important nuggets from the latest research. What's really impactful for your organization, especially if you're already leveraging AI.
Exactly. And what's truly fascinating here is watching how quickly these really abstract theoretical concepts are being engineered into practical tools. I mean, despite the formidable challenges that definitely still exist. Think of this deep dive as your shortcut, really, to understand precisely where quantum computing stands today. Not just the what, but critically, the why. Why it demands your strategic attention and how it directly impacts your industry, particularly as you navigate, the complexities of AI adoption.
All right, so to grasp where we're headed, maybe we should quickly ground ourselves in the basics, the sort of quantum leap, the core ideas, and the key milestones to get us to 2025. So most people working with AI know classical bits, right? Simple zeros or lensas. Quantum computers, though, use qubits. And the key difference is that qubits can exist in multiple states at once. That's superposition.
Right. And they can also be linked together intrinsically through something called entanglement.
Yeah.
So it's counterintuitive, but it's powerful.
And that combination unlocks this just unparalleled computational power, but for specific kinds of problems, right? Things classical computers, even supercomputers, just can't handle.
Precisely. The theoretical seed was really planted back in the 80s. Richard Feynman. He had this idea, that you'd need quantum computers to truly simulate quantum systems. Makes sense.
Yeah.
But progress was slow, really painstaking at first. The engineering challenge of just isolating and controlling these incredibly delicate quantum states was immense. Then, the early 21st century, that was a turning point. We saw breakthroughs like superconducting transmon qubits, that's a key hardware approach now, and crucial algorithms.
Like Shor's algorithm.
Exactly,
Yeah.
Shor's algorithm. That famously showed a powerful enough quantum computer could theoretically break a lot of current encryption. That really reignited massive interest, not just academic, but strategic. Governments, businesses, everyone suddenly paid a lot more attention.
Okay, so here's where it gets really interesting, leading up to now, 2025. You mentioned IBM. They've been providing cloud access to their quantum computers since 2016.
Yes, and that was pivotal, truly.
Because it democratized it, right. Suddenly, organizations without multi-million-dollar labs could actually experiment, play around with algorithms.
Massively accelerated the learning curve across the board. And it wasn't just IBM or the big players. We saw huge investment pouring in venture capital, plus major government pushes like the U.S. National Quantum Initiative.
A real R&D fire got lit.
Absolutely. And then there was Google's 2019 quantum supremacy claim.
Yes, the Sycamore processor. That stirred things up.
It did. It basically showed a quantum computer performing a very specific, tailor-made calculation exponentially faster than the best supercomputer could. Now, it was a powerful proof of concept for raw speed, even if the task itself wasn't immediately, practical day to day.
There was quite a debate about the utility versus just the speed, wasn't there?
Oh, definitely. A healthy scientific debate. But it undeniably showcased the potential and really fueled the competition. You have multiple platforms now superconducting, trapped ions, all competing fiercely. And that competition is just driving innovation incredibly fast, pushing boundaries constantly.
Okay, so the foundation's laid, the tech is advancing. The big question for business leaders, especially in AI-driven companies, is how is this power actually being used? Let's get into where quantum meets business industry applications. Because we're moving past hypotheticals now, right?
We are. The practical application phase is definitely underway. It's still gradual, of course, but it's happening across several sectors.
So what does this mean for your industry listening right now?
Okay, let's look at specifics where quantum's showing real, tangible promise, often in ways that complement or even supercharge AI. Take finance. We're seeing early but significant experiments in portfolio optimization, risk management, fraud detection.
Things AI already tackles, but quantum offers something more.
Exactly. It's not just about slightly better accuracy. It's the ability to model a vastly wider range of interdependent variables, nonlinear relationships, simultaneously. That unlocks optimization strategies and risk assessments that were just impossible before, classically, finding fraud patterns in real time across huge data sets.
So companies like JP Morgan, Goldman Sachs, they're actually using this.
They're actively exploring and utilizing quantum approaches for these tasks, yes, seeing the potential for really unprecedented market insights.
That's a fundamental shift, not just an incremental improvement, especially in finance.
It really is. Then think about healthcare and pharma. This is huge.
Drug discovery, personalized medicine.
Precisely. Quantum simulations can model molecular interactions at the actual quantum level. That means predicting how drug candidates will behave with much, much higher accuracy than classical methods.
Which cuts down R&D time dramatically.
Potentially dramatically, yes. We've already seen a case study where quantum computing, working with AI, is revolutionizing drug discovery for collagen toxicity, finding insights unattainable otherwise. It fundamentally changes the approach.
Wow. Okay, what about the more physical world? Logistics, supply chains, that seems like an optimization nightmare perfect for quantum.
It absolutely is. Logistics and supply chain management. Quantum algorithms are really poised to improve things like route optimization, complex scheduling, inventory management. Imagine dynamically rerouting thousands of delivery vehicles in real time based on unexpected traffic, weather, whatever, optimizing global supply chains with constant uncertainty.
That needs immense computational power.
Right, and there's a specific type, quantum annealing, that's particularly good for these complex optimization problems. It's being heavily explored for efficiency gains and cost reductions that were just computationally out of reach before.
And beyond moving things around, what about making things material?
Good point. Materials science, another major area. Quantum simulations are accelerating the design of totally new materials with specific enhanced properties.
Yeah.
By simulating quantum behavior electrons, atoms, you can engineer materials for a purpose.
Yeah.
Better catalysts for green energy, maybe higher capacity batteries.
Designing at the quantum level instead of just trial and error.
Exactly. It massively speeds up innovation cycles.
Okay, so summing this part up, we're genuinely moving past theory. There's demonstrable early-stage commercial viability, real impact is starting to emerge, and it feels like quantum isn't just next to AI, it's becoming a powerful accelerant for AI in these areas.
That's a great way to put it. The synergy is undeniable. Quantum can feed AI richer data, maybe even help optimize the AI models themselves. It pushes AI into new territory.
Now, though, we have to address the elephant in the room, security. As quantum computing gets more powerful, it poses a serious risk, doesn't it? The whole it could break current encryption thing.
Yes, that's a critical concern. We need new solutions because, yes, a powerful, fault-tolerant quantum computer, when it arrives, could potentially break many widely used encryption methods, RSA, ECC, the stuff protecting banking, comms, everything.
And this isn't some far-off worry. It's something businesses need to strategize for now.
Absolutely. If you connect this to the bigger picture, it's about future-proofing, building resilience today. And there are basically two main proactive solutions emerging. First is post-quantum cryptography, PQC.
New algorithms.
Essentially, yes. New encryption algorithms designed to be resistant to attacks from both classical and quantum computers. New math problems that even quantum struggles with.
Okay, and the second?
The second is quantum key distribution, or QKD. This is different, more hardware-based. It uses quantum mechanics itself, the weirdness, to create provably unbreakable encryption keys. Any attempt to eavesdrop on the key exchange actually disturbs the quantum state, alerting the users. It's fundamentally secure based on physics.
Right, and making this practical means standardization, doesn't it? We need everyone on the same page.
Crucial. And that's where organizations like NIST, the National Institute of Standards and Technology in the U.S., are vital. They're running a process to standardize these PQC algorithms. That ensures a smoother, secure transition for everyone. Enterprises, small businesses. It's designing the future of secure communication.
Is there market traction for this already?
Oh, yes. The market is definitely responding. Take QKD. The global market is projected to hit nearly, $2.5 billion US dollars by 2030, growing at over 30% per year. That number alone tells you the commercial interest and the critical need for these technologies is real and growing fast. For any executive handling sensitive data, this is not optional. It's a strategic must-have.
Okay, so we've seen the potential, the applications, the security imperative. Let's move into our fourth segment, navigating the quantum frontier challenges and executive actions. Because, let's be honest, despite the progress, significant hurdles remain. To be truly informed, you need to understand the challenges too. This isn't easy street yet.
Not at all.
Yeah.
And the challenges are layered. First, you've got fundamental technological limitations. Qubits themselves are just incredibly fragile, prone to errors from environmental noise, tiny vibrations, temperature fluctuations.
So maintaining their quantum state, their coherence, is hard.
Very hard. Keeping them coherent long enough to do complex calculations is a major challenge. And then just scaling up, getting more qubits while keeping them high quality and interconnected with low error rates, that's a massive engineering problem. Current machines are still what we call noisy intermediate scale quantum or NISQ devices. They're useful, but error-prone and limited. The big goal is fault-tolerant quantum computing.
Machines that can correct their own errors.
Exactly. That's where the real power lies, but we're still working towards it.
Okay, technology limits. What else?
Then there are implementation difficulties. Quantum hardware is expensive, really expensive. It needs specialized infrastructure, think ultra-low temperatures, vibration isolation. Plus, you need efficient quantum algorithms, which are often very different from classical ones, and user-friendly software tools to actually program and use these machines. Integrating them into existing IT, and especially AI workflows, is complex.
And the people to run all this, that's always a bottleneck with new tech.
A huge one. The skill gap and workforce development. There's intense demand for people skilled in quantum algorithms, quantum software, hardware engineering. It's a very specialized field, and the talent pool hasn't caught up with the demand yet. It's a global race for talent.
Okay, that paints a realistic picture. So this brings us to the crucial question for our listeners, particularly those leading AI teams. With these challenges, what should executives actually do right now? How do you prepare?
Right, action is key, even with the hurdles. First, prioritize exploring potential applications specific to your industry. Where could quantum give you a unique edge? Maybe solving problems your current AI struggles with. Identify that value proposition.
Don't just wait and see.
Definitely not. Second, figure out the talent piece. Invest in training your existing people. Hire specialists if you can. Or, very importantly, form strategic partnerships with quantum computing vendors or research groups. Bridge that expertise gap.
What about getting hands-on experience without buying a quantum computer?
That's the third point. Utilize cloud-based platforms, QCAS quantum computing as a service. It's relatively low cost, lowers the barrier to entry significantly. It lets your teams experiment, learn, build intuition, integrate quantum concepts into their thinking, even on a small scale initially. Invaluable experience.
Makes sense. And the security aspect.
Fourth, conduct thorough risk assessments. Understand how upcoming quantum capabilities might affect your current cybersecurity infrastructure. What data is most at risk? What's your migration plan for PQC?
Be proactive on post-quantum security.
Absolutely. And finally, fifth, develop an internal roadmap. How will your organization strategically integrate quantum over the long term? What are the milestones, the resources needed? Link it to your overall tech and AI strategy.
That's a really solid, actionable framework. Okay, let's pivot to our final segment, the road ahead future outlook.
Yeah.
So pulling this all together, what does it mean for the next few years? Where is quantum computing heading, and how might it really reshape the business and AI landscape?
Looking ahead, a few key trends stand out. First, as I mentioned, the push towards fault-tolerant quantum computers. The next, say, 3 to 5 years could see a real shift here. Higher qubit counts, much longer coherence times. That unlocks significantly more complex problem solving. Second, software maturation. We'll see more sophisticated quantum algorithms tailored for specific business problems. And the whole software development ecosystem, programming languages, libraries, tools will get better, more mature, easier to use.
So more powerful machines and easier for your teams to actually use them. That combination is key.
Precisely. Third, the democratization of access via QKS will continue. Lowering barriers, fostering broader innovation, making quantum tools available to more than just the tech giants or national labs.
And how does it play with other tech, like AI?
That's the fourth trend. Technological convergence. We'll see much deeper integration of quantum computing with AI, maybe blockchain too. Think quantum-enhanced machine learning, training AI models faster or on more complex data. Quantum-secured blockchains. These synergies will create powerful new capabilities, tackling problems even today's best AI finds hard.
And the ecosystem driving this, it sounds intensely competitive, but also collaborative.
It really is. You have the tech giants, loads of innovative startups, top universities, all forming strategic partnerships to speed up commercialization. And underpinning a lot of this is continued government funding worldwide, pushing the basic science and helping build that robust quantum ecosystem. It's that mix of competition and collaboration that's accelerating things so quickly. So while yes, big challenges remain engineering, scientific hurdles, The momentum is undeniable. The ongoing research, the increasing investment, the clearer roadmaps, it all points towards steady progress, more power, more applications, and ultimately transformative impact across many industries. The future isn't just bright, it's becoming tangibly real, but it absolutely needs strategic engagement now from leaders like you.
So as we wrap up this deep dive, it's amazing to think how far quantum computing has come by 2025. It really has moved from, theoretical musings in physics departments to a technology actively shaping finance, pharma, logistics, materials, offering fundamentally new capabilities.
Absolutely. And the key takeaway is that this isn't some distant future you could just watch unfold. It's a present reality demanding strategic thinking and proactive steps from business leaders, especially those already invested in AI. Understanding both the huge opportunities and the very real challenges that's crucial for navigating this field effectively and securing that competitive edge.
And for you, our listener, here's maybe a final thought to take away. As quantum computing continues its inevitable march, how will you ensure your organization isn't just reacting, but is actively shaping the quantum-powered future of business, especially thinking about how it connects with and potentially supercharges your AI strategy? Thank you for joining the podcast, and see you soon.